Welcome back. It's Mr. Angel with another exciting math video. This is 10-4 on the perimeters and areas of similar figures. We know that similar figures have corresponding sides that have the same ratio. That ratio is called the scale factor. It turns out that the scale factor, or the ratio of corresponding sides, is exactly the same as the ratio of the perimeters. However, the ratio of the areas is the scale factor squared. Okay, the scale factor squared. We can remember this by the units in which they're measured in. So if we are measuring, say, the perimeter of this rectangle here, and we have it in inches, what would be the perimeter's unit of measurement? It would be in inches. Right? Inches to the first power, if you will. If we were to measure the area of this, right, we would measure it in inches squared, inches to the second power. So you'll see that scale factor squared. So this goes very quickly. Right? The polygons here are similar. So what is the scale factor? The scale factor of the smaller one to the bigger one is 6/10. And if I simplify this, take a 2 out of both the top and the bottom, I get 3/5. Therefore, the ratio of the perimeters is also 3/5. And to find the ratio of the areas, I'm just going to square each of those. The ratio of the areas is 9/20. Question on that. Just square that scale factor. So let's take a look at this next one. The ratio of the lengths of corresponding sides of two similar rectangles is 4/11. What is the perimeter of the larger rectangle? The smaller one has a perimeter of 20. What is the area of the larger rectangle? The smaller one has an area of 60. So to solve these types of problems, we're just going to set up a proportion with these ratios. So the ratio of the lengths of corresponding sides of two similar rectangles is 4/11. Now I'm given the perimeter of the smaller one. Get it back up. So what I'm going to do is we have our smaller on top, larger on bottom. So I'm given the perimeter of the smaller one. It's 20. I'm going to put that on top there. And solve for x there. Remember how proportions work. We can simplify this a little bit by changing the locations of those. So we have x/11 equals 20/4. And can I simplify that 20/4? Sure, it's going to be 5/1. Now I can cross multiply from there, and I get x equals 55 centimeters. So the perimeter of the larger one is 55 centimeters. So now we can set up this same type of problem using the area. But now I'm going to do 4 squared to 11 squared. And then the area of the larger one is what we want to find. And then the smaller one has an area of 60. So this one shakes out real easily, right? What's 4 squared? That's 16/121. 16/x. So what does x have to be? So x is 121. And now this is centimeters squared. All right, the last example today. You run a pop copy, a print and copy store. The store charges by area. An 8 by 10 color photo is 42 cents. What should you charge for a 16 by 20 color photo print? So let's figure out the area of the smaller one and the area of the larger one. So the ratio of the sides is 2:1. So the ratio of the areas, 2 squared over 1 squared. And we want to solve for the larger one. This is the larger one here. This is a smaller one here. The smaller one is 42 cents. So notice the bigger one isn't going to be just 2 times the smaller one. It's actually going to be 4 times the smaller one. So I can cross multiply here. And I get x equals 4 times 42 cents. X equals 84 times 2, $1.60. For solving these proportions, it's similar figures involving area. I hope you enjoyed this video. Good luck with your homework.
Thank you.